Okay, I'm already started recording. I'll share the screen. Okay. Okay, so what we're gonna do for what we learned in chapter 3 include rules for differentiation, product and quotient rule, derivative of trigonometric function, chain rule, and implicit differentiation. Okay, so this is what you have to remember. We have constant rule, power rule, constant multiple, sum and difference, exponential, product, quotient, chain rule. It's very necessary that you know, you remember these rules and know how to use it. You guys want to take a screenshot or anything, you can. And also I upload the slides onto the file in Canvas, into the folder called supplemental. You can go there and download it. And also you have to know the trig identities too, and its inverse. So sine, cosine, tangent, and then the inverse of it. All right, so this is the first problem. I'm gonna give you guys 5 minutes to solve these, and then we'll go over it together. You guys already finished?
I got it, I think.
You got it? Okay. How about everyone else? Should I go over it?
Yeah, please.
Yeah. Okay. So what you do, we would go back to the rule, right? We see that we have a trig function here. And we see that it's being compound. You see the parentheses. So we have to use trig and chain rule, right? Okay, so this is my answer. You guys get the same answer?
Yeah, but like I have a question. Like, could you like also write it negative cosecant x cotangent x times 1 plus x to the power of 3 and not separate it out how you did it? Or is that a must that you have to write it like that?
How do you do it again?
Instead of like separating it out like you did, I just have negative cosecant x cotangent x times 1 plus x to the power of 3.
So you did like this, negative cosecant times cotangent?
Yeah, negative cosecant x times cotangent x, and then open parentheses 1 plus x to the power of 3, close parenthesis, instead of writing it 2 times like you did.
No, I think that's a different thing. That's a whole, yeah. Okay, so what we do is so we know that the derivative of cosecant is equal to negative cosecant x cotangent x, right? So what we do, we just substitute what's supposed to be x with what's inside the parentheses. So then it would be one like this. Yeah, that's why you can't do it like the way you said it. You have to put what's inside the parentheses into the x, substitute it. Does that makes you clear, or do I have to explain?
Yeah, thank you so much.
And you got, other than that, you got the answer the same as me?
Yeah.
Okay.
Can we try another practice problem?
Hmm?
Can we do like another practice problem, like another example?
Yeah. I have another practice problems. Okay. This one is okay. Now I'll give you time to do this one. Also, you guys can chat me. You guys can message me in the chat to say that you're done. Okay, so some of you guys are already done. Does other people need more time? Yes, no. Okay, I'll go over it. Okay, so is this the answer you get? Do you need me to go over anything? Do you need me to walk through how do I get this answer?
Yeah.
Yes? Okay. So
In the results, wouldn't you change the x to 1 in the first x? No, the first one.
yeah. This one?
No, like in the final result, the first x, could we change it to 1?
Yeah, we can change, we have to change it to 1. Or you can just don't write it at all.
And
Okay.
did you write
Mhm.
the x for, you put x as the derivative in the second, like in the first breakdown? So like usually in the derivative equation or the product rule, I think this is, wouldn't you do like the second part, like so not the x but like the arc sine, wouldn't that, like in that second placement, wouldn't you take the derivative of that one?
Yes, so if I write a prime letter at the symbol, that's mean that I'm gonna take derivative of this. This
No,
one is
I understand that part, but like usually what he would do is he would write it exactly the way you did it, right? But
mhm.
but in the first part he would take the derivative of the second thing, and then what he would do is he would flip this second part right here, so it'd be like arc sine x to the 2/3 times x, so it's like so that you could take the derivative of x, if that makes sense.
The
Like
thing is, yeah, the thing is the result is gonna be the same, right? Because it's doesn't matter. You have to. So the power rule is that it's like f derivative of x gx plus like this, or it can be vice versa. Is this answering your question?
yeah, so they're interchangeable, so it really doesn't matter, but it just
Yeah.
as long as you're keeping track of what you're taking the derivative of.
Mm-hmm.
Okay.
Yes, yeah. Because it's a plus sign, so it doesn't really matter. But if it's a minus sign, then you have to be careful, right? What about the derivative of square root? You know what? Yes, I forgot to do this one's supposed to be chain rule. So then right here, you're supposed to do, yeah, my bad. So then you would have 2/3 x minus b/3, which is equal to, right. Does that fix your problem, Mary? Yeah?
Yeah.
So basically you do x times the derivative of arc sine, but then since you're using chain rule, you multiply by 2/3 x negative to the negative 1/3.
Yeah, so this whole thing is a chain rule, right? If it's arc sine x, it will be just 1 over 1 minus x squared. But since we have a complex x in here, we have to do the chain rule. So yeah.
Was the 2/3 x?
Was it?
That's the part that was missing, and the chain rule was the 2/3.
Yeah.
Okay.
Yeah. I'm supposed to take derivative of inside and outside, right?
Okay.
Yeah. My bad. Okay, so should we move to next one? Yeah. All right. Find the equation of the tangent line to y equals 3x times with x cubed minus 4 at 0.01. I'll give you some time and then just message me when you guys are done. Okay, you guys, I think you guys want me to walk me through this one, right?
Yes.
Okay, so it says find the equation of tangent line. So when we see this, and he's definitely gonna ask for this, what does it mean by tangent line is that you must find derivative of this equation. So that's our first step. Find the derivative of the y, the equation y. And then, so once we get the derivative, what we're gonna do is that we're gonna insert the points 0 and 1 into the equation that's, the equation that's got derivative. We would put x in, and then we're gonna see what's the result. All right, and then the third step that we're gonna do is we're gonna use a point slope form. You guys remember what's a point slope form?
No.
No?
Is it y1 minus y2 or y2 minus y1 equals x1 minus or x2 minus x1?
Yeah. Y slope x. Right. So this formula is also very important for the test. So now, okay, so what I did here, so I started with this equation, right? And then I used the product rule. Product rule to get the derivative of the equation. So the product rule says, okay, so we keep this the same, and I find derivative of this to be this. I keep the second thing to be the same, and I take derivative of 3x to be this one. All right, so now we already get the derivative equation. You guys have any question until this point?
No.
No? Good, right? Okay, now as I said that we have the point 0 and 1, we were giving this point. So then the 0 is x, the y is 1. So what we do is we insert 0 for the x. So as you see here, we 3 to the power of 0 is equal to 1. 3 times 0 is 0. 0 to the cube, 0 cubed minus 4 is near 4. Natural log of 3 times 3 to the power of 0. So it's became natural log of 3 times 1, which is this one. All right, and then you do 1. It's supposed to be 1 plus near 4 natural log of 3. Raise it 1. No, I'm already right. I'm sorry. Okay, so 1 times 0 is 0. So then you have plus negative 4 times natural log of 3. So this is your answer. You guys have any questions? How I get to this point? Yes, no?
No.
No? No questions? Okay, yeah.
How do you know what to use for like? Because how do you know when to use chain rule? How do you know when to use product rule? Like, I know how to, okay, so I understand like product rules, like when you're multiplying, right? And but like, but how do you just know, like, to use that, like chain rule, like?
Okay, that's a great question. How do you know the chain rule versus, let's say, product rule, right? Because that's the most confusing. So if I say x times y and x to the power of y to the power of c, right? So product rule, you only use it when you times two things. It always have to be like x times y. But in some case of chain rule, it might be like this, or it always have to have parentheses. Like the y is inside of x, right? It's not like x times with y. It's like x, and the inside of x is y, and the inside of y is c or something. That is when we use chain rule, like when the something is inside. And when you can distinguish that there's an inside and there's an outside.
And then quotient rule would just obviously be like when you're just dividing.
Yes.
Okay.
Quotient rule, X. Does that make sense? Do you need me to explain more?
No, that was perfect. Thank you.
Okay. Okay, so we're here up until this point that we get to the minus x. What happens to minus x? What do you mean?
In the formula, I like brain fart. Like where did the m and then x minus x1
In this
in the
one?
bottom? Yeah.
The bottom? This
I
one?
like blacked out for a sec. Yeah.
Oh, okay. Yeah. Well, I'm about to explain it right now. So
Okay.
yeah, because we're not done yet. All right. So after we got this, so we know that this is a tangent. This is a tangent equation. And what we got out from tangent equation is always a slope. Do you need me to say it again, or do you guys already understand it? That when you put something into the tangent equation, you always get slope out of it, right? That's why we put this in the equation. We put this for slope, the m part. And for y0, so because we start at 0, 0, 1, for y0, we put 1 because that's where we start. And for x0, we put 0 because that's where we start. So that's why the x is gone, because it's x minus 0, which also equals to x, right? So this is your equation.
So the point slope formula is y minus y0 equals m times x minus x0?
Yeah, yes, but y2 minus y1 is also okay. It's just like y, yeah, you can use, it's like use interchangeably. You can use y2 minus y1 or y minus y0.
Okay, thank you.
Yeah. So if Professor Skidmore give you this on exam, are you guys able to do this?
Yeah, this makes a lot of sense. Thank you.
Okay. Yeah. And then I have one last problem for you. So I just want to make it clear that all of the example that I give it to you is the one that I modified from my test. So this is the realest you can get with the problems. Okay, do this one. I'll give you a lot of time for this one. Let's say I'll give you until 1:45.
Quick question, Lori.
Yes.
So in the exam, he expects us to memorize the velocity equation and the acceleration equation.
No. You don't have to remember. But what you have to remember is how to get the equation, not exactly the formula. Does that make sense? Yeah.
Okay. But he doesn't. But he doesn't write the equation on the exam or give us like any like formulas for the exam.
Like how you guys gonna have your exam format as? Do you have to do lockdown browser?
So far right now he's doing lockdown, but he's saying like if there's any inconveniences to email him, like he doesn't really know yet. Like from what it sounds like he doesn't know, but so far what he's planned for is to have lockdown browsers. But like I mean personally for me, like because he wants us to have like two devices, like one for Zoom and one for like the actual exam.
Mm-hmm.
A lot of people were saying that yeah, so anyways, but yeah, I don't know. It didn't seem like we figured it out, but so far as of right now it's locked down. So
Okay.
and he thought like he could do like so he also figured out like towards the end of class like he thought that he could do like a upload file thing like how he does with our homework and our quizzes. So he gets to work like during the actual exam that's on the lockdown browser. But I was telling him and a couple of other students were telling him that when we do that, we'd have to go somewhere else in our computer, like the files folder.
Mm-hmm.
And so it wouldn't necessarily work. So he was saying, so that's also another problem that came up. So I don't know if he's gonna change the format of the quiz or I don't know. I mean, he did come up with a solution for that, which was just to open up a Dropbox.
Mm-hmm.
Only open 30 minutes after the exam. So I don't really know what he's gonna end up doing, but
yeah, but you don't have to remember the velocity formula because this is not physics, right? This is calculus. So how are you supposed to tackle this question is by derivative.
okay.
Have he teach you guys this in class?
Yeah, we went over it, I think, before with homeworks and an example, I think.
Yeah. I'll give you guys 3 more minutes and then I'll go over it. Okay, so you guys want me to walk through?
Yes, please.
Yes. All right. So how you find the how you find the velocity and the acceleration from equation is just, so we have the original equation, right? Original equation. Then if you take derivative once, the first time, you get velocity. This is the first time you take derivative. And if you take derivative of that, so if you take the derivative 2 times, you get acceleration, right? So our equation is x equals t, or, right? And what would be the derivative of this equation? The first derivative.
4t to the third minus 3t to the second.
Uh-huh, right. So this is the equation for velocity. So now, what if you take derivative of this again? What is it gonna be?
It would be 12t to the second minus 6t to the just t.
Yeah. So that's it. That's how you get the answer. Yeah, and I don't have any problems anymore. This is all I have for today. So feel free to.
For the units, would velocity be meters per second and acceleration meters per second squared? Like in context of a problem, not this one.
Oh yeah. I mean, for unit, yes, but we don't have to care about the unit for this one because he just asked for equation. Right?
And this is for chapter 3, you were saying? So far?
Yes, this is in chapter 3. Everything we go through today is chapter 3.
Okay.
I mean, if you guys have more questions, I can stay until 2 to answer. I can answer any questions.
Thank you so much, though, for your clarifications. They really helped.
No problem.
Lori, can you go back to that slide where you wrote the difference between the chain rule and the product rule? I want to take a picture of that.
The thing is, I think I already.
Oh, you took it out?
Yeah, but I mean, I can write it again.
Okay, yeah, that'd be great.
But you understand what I'm trying to explain, right?
Yeah.
Okay. Is that good?
Yeah, thank you.
No problem. And how are you guys doing in calculus quiz? Is it hard or is it okay?
They're okay.
Yeah, they're fine.
They're fine.
I feel like the homework is super, like, hard.
Uh-huh.
Like, I feel like it's more complex than the lecture problems, but I mean, I talked to him about it over lecture, and he said that there's like it's usually like that. So
Yeah. So after now, I'm gonna always have my SI office hour open for you guys, so you guys can come and ask questions about the homework And I only do something like this only when it's almost exam time, right? Yeah. So other than that, I can help you guys with question and homework during this time.
And I think the reason why I guess it gets like really confusing sometimes is because there's so many, like especially in the beginning of the slides, like if you saw like exactly like what you had written down, it was an organized way of like keeping all of the theories you have to keep in mind. And I think that's why it gets really confusing and super complex at certain times, is because we have to memorize all the memorize like all those like theories in a way, or like keep in mind. But I like how you wrote them like really like neatly and organized, so I'll definitely take a look at that and kind of like study that, because I think that's like the whole foundation and basis of what this entire chapter is. So I think that once I have that down, everything will kind of like fall in line.
You mean the one that I do it for you guys, right?
Yeah, like the trig identities and the rules for the identification. Yeah.
Yeah. I do this because when I was taking calculus, nobody do this for me, right? All right, we don't do this kind of stuff. Yeah, so there's only one tutor for calculus, and her schedule is all booked up for the whole week, and basically I didn't get any help at all. I feel so, how to call it, like mad and frustrated because I didn't have any help. So I would want to provide what I wish I have during when I was taking calculus for you guys. Yeah, but you guys have any question, or you guys can feel free to go. This is all I have.
Okay, thank you, Wari. Have a good weekend.
You too. No
Thank
problem.
you, Lori.
Oh, thank you.
Oh, also for that OChem textbook, so you said over Outlook?
Wait, I already got your Gmail. I'll try to send it through that.
Okay.
Sure. Yeah.
Thank you so much again. I really do appreciate it.
No problems. Okay. Bye.